Today's lesson is on the properties of parallelograms. We're going to continue on with chapter 6. This is section 6.2. All right, so today's objectives are, by the end of the class, you will be able to use facts about parallelograms to solve problems. Specifically, the opposite sides of parallelograms are congruent, the opposite angles of parallelograms are congruent, the diagonals of parallelograms bisect each other, any consecutive angles are supplemental, and then also you'll be able to use the fact that if three or more lines are parallel and the segments of one transversal are congruent, then the other segments of another transversal are also congruent. So we have two main objectives and four sub-objectives today. All right, first we have to put in some notes here. So for a quadrilateral is simply a four-sided polygon. Someone who has quadriplegia, can't move four legs, or four limbs. Quad means four, so a four-sided polygon. The opposite sides are the sides in a quadrilateral that do not share a vertex. Here is a quadrilateral here, and these two red sides are opposite sides. They're opposite each other, they don't share a vertex, they're across from each other. These blue sides are also opposite sides, they don't share a vertex. A parallelogram is a quadrilateral with both pairs of opposite sides parallel, and it has a special symbol, and I've written that symbol down there. Opposite angles are the angles in a quadrilateral that do not share a side. So for example, these two red angles are opposite angles, and these two blue angles are opposite angles. And then finally, consecutive angles are angles in a quadrilateral that do not share a side. So for example, these two are opposite angles. Consecutive angles. These two are consecutive angles. These two are consecutive angles. These two are consecutive angles, and these two are consecutive angles. Okay, you can pause the video to make sure you get this down in your notes here. So today we're going to begin learning about quadrilaterals. A quadrilateral is a four-sided polygon, and we have to become familiar with several types of these quadrilaterals. So any four-sided figure like this is a quadrilateral, and we divide them up into categories depending on how many sets of parallel sides they have. If they have two pairs of parallel sides that are opposite, then it is what's called a parallelogram. If the parallelogram has four right angles, it's called a rectangle. If the parallelogram has four congruent sides, it's called a rhombus. If the parallelogram is both a rectangle and a rhombus, it has four right angles and four equal sides, then it's called a square. The second group of special parallelograms, or special quadrilaterals we have, is if it has one pair of parallel sides, at which point then it's called a trapezoid. And if it so happens that the two non-parallel sides of that trapezoid are congruent, then it's called an isosceles trapezoid. And then finally, we have special quadrilaterals that have zero pairs of parallel sides. If it has two sets of consecutive sides that are congruent, then it's called a kite. So these are all the different types of quadrilaterals that exist, and today we're going to be talking about just parallelograms right here. All right, so let's talk about some facts about parallelograms. The opposite sides of parallelograms are parallel. So for example, DA is parallel to CB in this diagram that I've over on the left, and DC is parallel to AB. It's also true that opposite sides are congruent, as it shows up above here. So if the opposite sides are congruent in our triangle over on the left, DA is congruent to CB, and DC is congruent to AB. Okay, so using our, going back to our objectives, the opposite sides of parallelograms are congruent here. You can try example problem number 1. Push pause and try example problem number 1. All right, so example problem number 1 is asking us to find side xy in this parallelogram here. Well, if it's a parallelogram, we know that WZ is equal to XY. So we know, therefore, that the side 3x minus 3 is equal to x plus 13. So we can just add 3 to both sides. We can subtract x from both sides, divide both sides by 2, and we get that x equals 8. Now that we know x equals 8, it's asking us to find xy, which is x plus 13. So that would just be 8 plus 13, which equals 21. So we know that xy is 21. And just to double check, we can check WZ equals XY. So WZ equals 3x minus 3. That would be 3/8 minus 3. That's 24 minus 3. That's also 21. So now we know we did it right because we found x correctly because we did it twice and got the same answer both ways. So we know that xy is 21. Moving on in our notes here, we know that opposite sides are congruent. So, opposite angles are congruent. So we know that angle ADC is congruent to angle ABC, and we know that angle DAB is congruent to angle DCB. So let's use that fact to try example problem number 2. Push pause and try example problem number 2. In example problem number 2, in the parallelogram EFGH, it's asking us to find angle G. And we know it's a parallelogram, so these opposite angles, angle E and G, the measures of them must be equal. So 41x minus 2 equals 39x plus 2. If I add 2 to both sides, subtract 39x from both sides, and then divide by 2, I get x equals 2. So to find angle G, I can just plug it in there. That's 39x's plus 2. That's 39.2's plus 2. That's 78 plus 2. That's equal to 80. And once again, we can check this because we know that if we did it right, angle E must be equal to angle G. So I'm going to find angle E as well. Angle E is 41x's minus 2. That's 41.2's minus 2. That's 82 minus 2. That's 80. Yep, I got 80 for both, so I know I must have done this correctly. The answer is that angle G equals 80. All right. Moving on, we see that in parallelograms, diagonals bisect each other. So what that means is that in this diagonal here, that dr must be equal to br because r is the midpoint of db because db is bisected by AC. And similarly, we know that AR is congruent to CR because R is the midpoint of AC because AC is bisected by DB. So pause, take this in your notes. And then we can move on to our next objectives that diagonals of a parallelogram bisect each other by trying example problem number 3. Push pause and try example problem number 3 on your own. In example problem number 3, it tells us that EFGH is a parallelogram and that FD, and it's giving us the values of FD and DH and asking us to find the value of FH. So to do that, we know that EFGH is a parallelogram, so the diagonals bisect each other, so D must be the midpoint of FH, so therefore FD must equal DH. So 2x minus 3 must equal x plus 7. If I add 3 to both sides, subtract x from both sides, I get x equals 10. So I can now try to find FD, which is 2x's minus 3. That's 2 tens minus 3. That's 20 minus 3. That equals 17. And if I find DH, it better also be equal to 17. That's x plus 7. That's 10 plus 7. That's 17. So I know I did it correctly. I got two 17s. Now it's asking us to find FH, which is both of those 17s added together. So it must be 34. So I know that FH equals 34. Moving on in our notes, we know that consecutive angles are supplementary. So any consecutive angles are supplementary. So for example, the measure of ADC plus DAB must equal, if I add the sum of those, must be 180. The sum of the measures of angle DAB and ABC must equal 180. If I take the measure of angle ABC and add it to the measure of DCB, it's equal to 180 because they are supplementary. And then finally, the measure of angle DCB plus the measure of angle ADC, together that equals 180. So push pause, take this for your notes. And now we can move on to our fourth sub-objective, that any consecutive angles are supplemental. So try example problem number 4. Push pause, try this on your own. All right, in parallelogram DEFG, it's asking us to find the measure of angle D. And in a parallelogram, D and E are consecutive, so they must add up to 180. So 7x plus 10 plus 9x plus 10 must equal 180. That's 16x plus 20 equals 180. Subtract 20 from both sides, that's 16x equals 160. Divide by 16, and I got x equals 10. Now it's asking us to find the measure of angle D, so that's 7x's plus 10, that's 7 tens plus 10, that must be 80. And to check it, what I can do is I know that the measure of angle D plus the measure of angle E equals 180, so the measure of angle E is 9x's plus 10, that's 9 tens plus 10, that's 90 plus 10, that's 100. And 100 plus 80, of course, is 180, so I know I did this correctly. The measure of angle D is indeed 80 degrees. All right, moving on to the next part of our presentation here. If one transversal segment's congruent, then another transversal segments are also congruent. So here's our theorem right here. And what it's showing us is that if I have three lines that are parallel here, in this case line L, M, and N are parallel, and I draw a transversal, we'll draw this transversal in red here, and it shows us that the measure of AB is equal to the measure of BC, then if I draw another transversal, in this case QS, then I know that the measure of QR is equal to the measure of RS. And if I drew yet a third one here, this one in blue, XZ, then I know that the measure of XY is equal to the measure of YZ. No matter which transversal I draw, the two sections of the transversal are always going to be congruent. So we can use that fact, pause and take this in your notes here, and then once you do, we can come back and use this fact to solve a problem. We can try problem number 5, which is asking us to find the values of all of these given what we have here. So pause and try this in your notes here. All right, so looking at QR, RS, and SR must all be congruent. That's what it's telling us in in the example here, it's telling us that PQ and QR and RS are all congruent. Therefore, we know that the sections of these other transversals must also be congruent. So right here, ZU must be equal to the same thing as TZ, so it must be 3. TU is, I'm sorry, XZ, excuse me, XZ must therefore also be 3. And TU, this one plus this one plus this one, must be just 3 plus 3 plus 3, so that's 9. If I look at XZ, well, XZ is the same thing as WY, so it just must be 2.25. XY, or YX, must also be 2.25 because all the sections of the transversal are congruent. If I look for YV, YV is this piece plus this piece, that's two 2.25s, that must be equal to 4.5. WX is just equal to WY plus YX, so that's again is two 2.25s, that must be 4.5. And finally, WV must be equal to this section of 2.25 plus this section of 2.25 plus this section of 2.25, put them all together and I get 6.75. All right, you can spend the remainder of the class working on the homework in IXL LLK.